So the next problem says use synthetic division to prove that x plus 3 is a factor. So just looking at the verbiage here, you know that x plus 3 has to be a factor. So if you don't get the 0 at the end, you probably did something wrong. So because x plus 3 is a factor, the opposite, the potential 0, goes in the box, which would be negative 3. Then I'm going to do the coefficients. Now, notice we have x to the fourth, 4x cubed, and we don't have an x squared. So we're going to have to put a 0 in for the x squared spot. So this is x to the 4, x cubed, x squared, 0x squared, then x, and then number. So the 1 drops down, and then I multiply 1 times negative 3, which is negative 3. Add down, you get 1. Multiply 1 times negative 3, which is negative 3. Add down, you get negative 3. Negative 3 times negative 3 is positive 9. Add down, you get negative 4. Negative 4 times negative 3 is positive 12, and negative 12 plus positive 12 is 0. So yay, I was able to prove it. So now you have to make some sort of statement. Therefore, x plus 3 is a factor. You need to write something so that I know that you know that we were done and that we proved it. The next problem, number 24, says find the following information for the given function. State all multiplicity of the zeros and then graph. So because this is factored, it makes the zeros easier to get, but it makes the degree and leading coefficient and behaviors a little trickier because you don't have the leading coefficient degree is set out in the beginning. So what I'm going to do is I'm going to multiply the x values and their exponents from every single factor. So we have x times x cubed times x squared, and when I multiply that all out, it gets me x to the 6th. Clearly there's a bunch of other stuff that's going to be there, but I'm not even worried about all that. If I spent the time to distribute it out, I wouldn't have time for the rest of the test. So I just need to multiply the first part of each of the things out to find the first term. So my degree is 6 because that's the exponent. My leading coefficient is 1. With an even and positive, that's up and up. My zeros, I just set each of the factors equal to 0. So when I set x plus 1 equal to 0 and solve, that gets me negative 1. I set x minus 1 equal to 0 and solve, that gets me 1. But because there's a 3 on it, it's multiplicity of 3. It would pop up 3 times. And then I have x plus 3 equal to 0, so when I solve that, I'm getting x equals negative 3. But that one also is multiplicity, that's multiplicity of 2. Once I have the multiplicity correct, I just set each of those comma 0 to get the x-intercept. In the y-intercept, I'm going to find f of 0. So to find f of 0, in this case g of 0, I'm going to plug in 0. Now a lot of times students go too quickly on this step. When it's already factored, you need to be a little bit careful. It's not just 0 times 0 times 0 and 0. That's not true. Because the PEMDAS says do the parentheses first. So inside the parentheses, I'm taking 0 times 1, which is 1, not 0. And then 0 minus 1 is negative 1 cubed, and then I have 3 squared. So this is 1. Negative 1 cubed is negative 1. 3 squared is 9, so I get 0 comma negative 9. So now I can plot all the values that I have. I have one at negative 1, I have one at 1, and I have one at negative 3 for the x-intercepts, and then I have a value at 9. Now, as a reminder, some of these things are going to go through, and some of these things are going to bounce, and some of these things are going to wiggle. The negative 1, because it doesn't have any multiplicity, that one's going to go straight through. 1 comma 0, that one has multiplicity 3, so that one is going to wiggle. It's going to go through, but with a wiggle. And then at negative 3 comma 0, because it's multiplicity 2, it's going to bounce. My end behavior starts up and ends up. So the first thing I'm going to come to is the negative 3. So I'm going to go look at my instructions. My instructions say, because it's multiplicity 2, I need to bounce. So that needs to touch and turn around. The next thing I need to touch is negative 1, and that says straight through, because it's multiplicity 1. So I'm going to go straight through. I need to tag the negative 9. I need to make that negative take the negative 9 and come up to the 1. Now what happens at the 1? I have a wiggle. So I'm going to put a little flat line right there, and I'm going to wiggle up and wiggle down to get the other values to touch. Now please don't go like out like that. That's not good because that is not a function. You have to keep going forward, so make sure that you don't come back on itself. And that is the graph of that problem. So for this problem, it says find the following information for the given rational function and graph. So the first thing I'm asking for is domain. To find the domain, we set the denominator not equal to 0, so I have x minus 2 not equal to 0. So then I'm going to solve by adding 2 to both sides, and x cannot be equal to 2. Now that's not what we're going to write on the line of domain. The domain is an interval notation, and it's all the values it can be. X is not equal to 2 is the value it can't be. So the way we write that is negative infinity all the way up into 2. Those are the values you can have. We're not allowed to have 2, so we put an open parentheses, union 2 to infinity. Those are the more values we're allowed to have. So for vertical asymptote, I set the denominator equal to 0. Notice there's no holes here in the list, so there's no holes or point crossing the horizontal asymptote. You don't have to worry about that if it's not in the list. So I set my denominator equal to 0, and that gets me x equals 2. And the way we write that is x equals because it's a vertical line. So in red, I can come over here and draw my vertical line. The horizontal is a chart, and the chart says to compare the degree of the numerator with the degree of the denominator. Because the degree of the numerator and the denominator are the same, my horizontal asymptote is the coefficient over the coefficient, which is 5 over 1, or just 5. So I'm going to go ahead and plot that in green at 5. Next, I'm looking for the x-intercept. The x-intercept, we set the numerator equal to 0, and we put it in an ordered pair. Technically, you could set the whole function equal to 0, but it turns out that if the numerator is 0, then the whole function is 0, because 0 divided by anything is 0. So this is the shortest way of doing it. So that gets me 6/5. And the y-intercept, as in all the other problems before, is always f of 0. So that gets me 0 comma something. So that gives me -6 over -2, which is 3. So I have a point at 0 comma 3, and I have a point at 6/5. Now 6/5 is like 5 goes into 6 one whole time with a little bit left over, so that's 1 and a bit. So I have that point right there. So at this, I know I have a branch on the left side over here. I know it has to cross through these 2 points, and it has to get close to the asymptotes. So the question is, do I have a branch up the top, or do I have a branch in the bottom? Trying to figure out which one I have. Let's see. I could plug another point in. That was one thing I can do, like I could plug in 3. But if the branch was down here, what would you notice? It would have another x-intercept, and we don't have another x-intercept. So by deduction, we can tell that it has to be this branch up here. Okay, so it has to be the branch up there, and if that's all you draw, that is plenty. Now, if you don't believe me, you're welcome to plug in 3. We can do 5 times 3 minus 6 over 3 minus 2. That gets me 9. 15 minus 6 is 9. 9 over 1, which is 9. So at 3 comma 9, which, oh my goodness, I did actually a pretty good job. That's the point, and so you could graph it that way. But if you realize that there's no other x-intercept, well, then it has to be on the top half. It can't be in the bottom half. It's a little bit easy to do it that way.